Alright, so what is the empirical formula? Well, a simple definition for it would be that you're essentially getting the lowest whole number ratio between the atoms of elements in a compound, right? So this will make sense when we do a practice problem, but essentially when you are given, say, grams, or in our case percentages, which you can convert to grams, you're going to find the number of moles, and then from there you're going to find the ratio between the moles, their closest whole number ratio, and from there you can find the empirical formula, which encompasses that very characteristic. So let's scroll down here and you'll find that everything is in percentages right now, right? 40% nickel, 16.4% carbon, 43.6% oxygen, and we need to convert this to the empirical formula. So first thing you need to realize here is that all the percentages add to 100%. And so there's a direct relationship here between the grams and the percentages. And so we can just assume that for nickel, there's going to be 40 grams. Put that over 1. For carbon, it's going to be 16.4 grams of that in this compound over 1. 43.6 grams for oxygen over 1. And like always, if we're trying to find the moles, we're just going to set up our equivalent fractions. The moles will be on the top, right? Because that's what we're trying to get. And now we just need to find the atomic mass of each of the elements. For nickel, it's going to be rounded to 58.7. Carbon rounded to 12, oxygen is 16, and this is going to give us that value for moles. This is going to give us this, and this will give us that. All right, so from here you want to identify the lowest value here, right? Because you're trying to find a ratio, and so in order to get that ratio and get whole numbers, you want to find the lowest number in which you can divide everything else to get that ratio. So in our case, this is going to be the lowest, right? This is a little victim here. So we're going to bring everything down and divide. 0.6 divided by itself, that's just going to give us 1, right? That's one part of our ratio right now. And let's just do everything else. 1.3667, remember these are moles and we're just dividing them by the ratios of each other. That's going to give us, not exactly 2, but that's going to give us approximately 2. And it doesn't have to be exact, but it needs to be close enough so that the values do match up. And you have 2.725. divided by that, that's going to give us approximately 4. Alright, so you'll find that you're going to have this little ratio here, 1 to 2 to 4. And each of these link with one of the elements, right? This one right here is linked to the nickel. This one right here to the carbon, and this one right here to the oxygen. So now we can write them correctly. So we're going to have 1 nickel, and then for carbon, we're going to have 2 because that's the ratio. And then for oxygen, we're going to have 4. And that there is your empirical formula. You'll find that that is the simplest simplification for this problem because you can't divide this any further, right? Let's say you had carbon 2. Sure, you can divide it by 2, right? You'll get 1 carbon. And you can divide oxygen 4 by 2 as well to get O2. Except the nickel now, you can't divide it. You can't have nickel 0.5. That just doesn't exist, or at least doesn't exist when you're trying to get it in simplest terms for the empirical formula.